Hi, in this video we will go over the exercise questions in chapter sound, and as before, we have the responses here, but we will go over them in detail. Let's start with the first one. What is sound and how is it produced? So we know that sound is a form of energy, and the sound is created when an object begins to vibrate, and it needs a medium to propagate. That vibration is acted on the nearby air particles or the particles as part of any medium, and that continues as a chain, and that's how that's how sound propagates and reaches our ears. Describe with the help of a diagram how compressions and rarefactions are produced in air near a source of sound. So take the case of a tuning fork, which is a vibrating tuning fork, and this vibrating object, it actually alternates between push and pull. Right? It pushes the nearby air particles, it pulls the air particles. Now, which means that your push creates a high pressure in one direction on the nearby air particles, and the pull creates a high pressure in the opposite direction. Right? So this push and pull of this object, this alternating push and pull, creates an alternating variations in both pressure as well as the density of the air particles. Right, and that's how the high pressure or high density air particles are shown here, and the low density low pressure air particles are shown here, and this alternates because the object keeps pushing and pulling, right? It keeps vibrating, and so this part is what is called as compression. The air is all compressed, and this is what is the low pressure area is what is called as rarefaction. And that is how a sound wave is formed, by alternating compressions and rarefactions, which is caused by the alternating push and pull of the vibrating object. That is how sound waves are created. Cite an example to show that sound needs a material medium for its propagation. So we went through that example of an electric bell inside a jar. And when the jar is when the air inside the jar is completely sucked out, we will see that we'll not be able to hear the electric bell, although the electric bell rings inside the jar. That's because because there is no medium for that sound to reach us. So, and the electric bell inside a vacuum jar is a good example to prove that sound needs a medium to propagate. Why is sound wave called a longitudinal wave? So as we saw earlier, so sound propagates by pushing particles on the side, right? It keeps pushing the nearby. The vibrating object pushes the air particle, pushes and pulls the air particles on the side, right? So that is how sound is propagated from one particle to the other, and this is the direction of the sound wave, right? But and whereas waves like light or water propagate in this direction from left to right, but however the particles actually move up and down, right? So the sound waves move in a line that is parallel to the propagation of the sound, whereas light waves move in a direction that is perpendicular to the propagation of the particles in a light wave move in a direction perpendicular to the direction of the propagation of the light. So that is why it's called longitudinal wave, because the push and pull happens on the side. Which characteristic of sound helps you to identify your friend by his voice while sitting with others in a dark room? So we learned that one of the subjective characteristic is timbre, which helps us differentiate voices when we are on a Zoom call or on a dark room. When the frequency and the amplitude are the same, still through timbre we can identify. Our ears are able to identify the right person. Flash and thunder are produced simultaneously, but the thunder is heard a few seconds after the flash is seen. Why? We learned it because the speed of the sound is much lower than the speed of light. To give an example, it's approximately 330 meters per second. The speed of sound is 330 meters per second on air, whereas the speed of light is approximately 3 into 10 power 8 meters per second on air. So this is way faster than the speed of sound. So the light reaches us fast. although the flash and thunder happen at the same time, the light reaches us fast, so we are able to perceive light first, while thunder takes time to reach us, and that's why we see the thunder later. A person has a hearing range from 20 Hz to 20 kHz. What are the typical wavelengths of sound waves in air corresponding to these two frequencies? Take the speed of sound in air as 344 meters per second. Okay. So we have so we are given the frequencies and we are asked to find the wavelengths at these two frequencies, considering this to be the speed of sound. Okay. So speed is nothing but distance traveled by time, and frequency is nothing but number of oscillations over time. Now, if you put speed over frequency, then it becomes these time and time gets cancelled. So speed over frequency becomes the distance by the number of oscillations, and that is nothing but the wavelength. Because if the number of oscillations is 1, then the distance the distance covered will just be the distance covered by 1 oscillation, right? So speed over the frequency is equal to lambda. So which is the wavelength. So the wavelength at 20 Hz is going to be 344, which is the speed over 20, which is 17.2 meters. And the wavelength at 20 kilohertz is going to be, once again, speed over frequency, which is 344 by 20,000 Hz, which is 0.0172 meters. Two children are at opposite ends of the aluminum rod. One strikes the end of the rod with a stone. Find the ratio of times taken by the sound wave in air and in aluminum to reach the second child. So here we are expected to find the ratio of the time, right? So let's consider the aluminum rod to be of d meters. So this is the aluminum rod. And the speed of the, so we are asked to find the time taken as a ratio between the sound wave that goes through the aluminum rod and the sound that goes through the air, right? So speed of the sound in air, if you consider it as VAIR, it is nothing but the distance traveled by the time taken by that sound in air. So let's call it T air. This is one equation. And the speed of the sound in aluminum is equal to VAL. If you consider that to be VAL, it is equal to D over TAL. TAL is the time taken by the sound in aluminum. Now, if you divide 1 over 2, we get, the ratio of the time taken by sound in air to the ratio of time it takes in aluminum is the ratio of the velocity with which it travels in aluminum over velocity with which it travels in air. So TAR by AL, TAL is equal to V aluminum by V air. So that is the ratio. So let's go to the next one. The frequency of a source of sound is 100 Hz. How many times does it vibrate in a minute? So a frequency is nothing but oscillations by time. So oscillations is the number of time it vibrates, right? So in 1 second it vibrates 100 times. So in 1 second there are 100 oscillations. In 1 minute there are 60 seconds. So there are 60 into 100 oscillations, which is 6,000 oscillations. Does sound follow the same laws of reflection as light? That's explained. We did learn that sound travels, sound follows the same laws of reflection. It bounces off liquids and solids, and with the same angle, right? We found that, if the angle at which it hits, which is basically the angle of incidence, is always equal to the angle of reflection, and both the angles are the same for sound wave. And this is how light waves also, this is the property that light waves also exhibit. So yes, sound follows the same laws of reflection as light does. When a sound is reflected from a distant object, an echo is produced. Let the distance between the reflecting surface and the source of the object production remain the same. Do you hear echo sound on a hotter day? Okay. Hotter day, we know that, hotter day means the temperature of the medium is higher, right, as compared to a regular day. And we know that sound travels faster when the temperature of the medium rises, right? So on a hotter day, the sound is going to travel much faster than on a normal day. So, and we also know that as long as the delay, as long as the distance, as long as the time delay is greater than 1 second, 0.1 seconds, our brain can process the echo and recognize it as an echo. So, on a hotter day, as long as the sound reaches back in less than 1 second, the echo will not be heard. But if the sound takes more than 0.1 seconds on a hotter day to reach us, then echo will be heard. Give two practical applications of reflections of sound waves. We saw quite a few examples, practical examples are, the curved ceilings on concert halls, so that, sound is able to reach all the nook and corner. Megaphone, wherein we are able to channelize all the sound and ensure that all the sound waves are propagated in one single direction. That is one example. Stethoscope, so that all the vibrations of the heart is exactly felt and channelized through the stethoscope tube all the way up until the doctor's ears. Right. So all these are practical applications of reflections of sound waves. The primary use is to channel and orient the sound waves and maximize the effect. So that's the idea. Question 13. A sound is dropped from a top of a tower, which is 500 meters high, onto a pond of water at the base of the tower. When is the splash going to be heard at the top? Given gravity is equal to 10 meters per second square, and the speed of sound is equal to 340 meters per second. So the time taken to hear the splash is equal to, there are two parts to it. The time taken for the stone to hit the water, let's call it T1, plus the time taken by the sound to reach the top, that is T2. So you have dropped the stone from the top. So the stone has to first reach the water, that is time T1, and then the sound has to reach back the person who's standing on the top, right? So that is T2. So for T1, we know that, from the laws of motion, we know that, the distance traveled is equal to ut plus half gt square. And we know that u is 0 because the stone was at rest before being dropped. So with that, you will be able to solve for t from this equation. You will be able to solve for t to be 10 seconds. Now for T2, which is basically the time taken by the sound to reach the top. So we found that, the speed of the sound is 340 meters per second, which means that, in 1 second it covers 340 meters. So to cover 500 meters, it would take 500 over 340 seconds, which is 1.47 seconds. So the total time is equal to the sum of these two, 10 and 1.47, which is 11.47 seconds. Question 14. A sound wave travels at a speed of 339 meters per second. If its wavelength is 1.5 centimeters, what is the frequency of the wave? Will it be audible? Okay. So from question 7, which is basically this, from question 7, we found that, speed by frequency is equal to the wavelength, right? So let's use that. So speed over frequency is equal to wavelength. Now, when we replace the speed with 339 and frequency to 0.0015, sorry, my bad. So speed over frequency is equal to wavelength. So which means that, when you bring wavelength to the denominator and get frequency on top, we get frequency is equal to speed over wavelength, right? And which is equal to 339 by the wavelength is 1.5 centimeters. When you can convert it into meters, it is going to be 0.0015. And which comes down to be approximately 22.6 kilohertz, and which is clearly over the audible frequency range, which is 20 hertz to 20,000 hertz. So this is not going to be audible. What is reverberation? How can it be reduced? So reverberation is the repeated echo, right, within a closed surface, where within a closed environment, where sound keeps reflecting from one surface to the other, and you keep hearing the same thing again and again. So that is, reverberation is nothing but the recursive reflection of sound, something like this. And this can be reduced by introducing, with certain, absorbing materials, absorbing fibers that can absorb the sound, so that you can reduce this, reduce the possibility of sound getting reflected more, right? So that is how we reduce reverberation. Question 16. What is loudness of sound? What factors does it depend on? So we understood that loudness is one of the Loudness is one of the subjective characteristics of sound, and loudness is the ear's response to the amplitude of the sound. Right, higher the amplitude, we say it is very loud, and it is subjective, as we just spoke about. And it depends on the two things. One is obviously the amplitude of the sound, and also the sensitivity of one's ear. Right. Question 17. Explain how bats use ultrasound to catch the prey. So, just like the technology behind sonar, wherein there is a transmitter of the sound and there is a detector of the sound, and based on the time it takes between transmitting a sound wave and receiving the sound wave, the sonar finds how deep the ocean is. Just like that, the bats also emit ultrasound waves, and based on the reflection from the insect or the object, it can detect how far the insect is, and that is how the bats are able to find out where exactly its prey or the target is. So it is based on the reflection of its ultrasound waves. How is ultrasound used for cleaning? So as I mentioned, as we discussed in the chapter, so when there are small places, small corners where you really cannot insert a brush or anything, and if there is dirt, we typically fill that place with the cleaning material, and then we direct ultrasound. We emit ultrasound waves to it. So what happens is, owing to its high frequency, the vibration is going to be very high of these ultrasound waves, and this high vibration of these ultrasound waves will go and vibrate the dirt in that corner, and the dirt will come out along with because you have already filled it with cleaning liquid, and that's how it will you'll be able to clean those micro corners, right? Explain the working and the application of a sonar. So we discussed this. A sonar is a device where you have it stands for sound navigation and ranging. So typically, the purpose of a sonar is to emit ultrasound waves from the ship. There are two parts. There is a transmitter and there is a detector part. And the transmitter emits the ultrasound waves, and it travels all the way to get reflected back by the surface of the earth or whatever is the object that is out there. And then based on the speed and the time it takes for the detector to receive back the sound, the sonar device will be able to determine the distance between the ship and the seabed, and that's how sonar operates. Question number 20. A sonar device is on a submarine, sends out a signal and receives an echo 5 seconds later. Calculate the speed of sound in water if the distance of the object from the submarine is 3625 meters. So here the total elapsed time from the transmitter to the detector, that is the total echo time, is 5 seconds. The total distance traveled is 3625 into 2 meters, because this is only the depth. The distance of the object from the submarine is 3625 meters, but the total distance traveled by the sound is 2 times that, which is 2 times 3625 meters. So speed in water is equal to the total distance traveled by time taken. So which is 3625 times 2 by 5, which comes down to 1450 meters per second. Explain how defects in a metal block can be detected using an ultrasound. So as we spoke earlier, in the main section, so if in a hard object, imagine this is a metal block. Sound travels. This is a medium where sound can travel. So if you emit ultrasound waves from one side and place detectors on the other side, they should be, if there are no disturbances in the medium, it should be able to detect them seamlessly on the other side. However, if there is a crack or something, that sound waves that you're going to send is not going to go through that. It's probably going to come back, right? Because this crack will have a vacuum. There is not going to be any air particles in it because it is inside the object. So which means that the sound will not be able to propagate. So it will possibly come back to the source, and the detectors that are placed here will not be able to catch that sound. And that is how we can find out that if there are any defects internal to that object. Explain how the human ear works. So I have once again placed the section here, which is, let me maximize this. Okay. So human ear, there are three parts to the human ear. One is the outer ear, the middle ear, and the inner ear. The whole the purpose of each part is to primarily to receive the sound waves, direct the sound waves, sense the sound waves, and then amplify, and then convert them to electric signals, and then pass it on to the brain. So that is a whole set of activities that is performed by the ear, right? So let's start with the outer ear. So the whole purpose of the outer ear, which is called pinna, is to receive the sound waves. So the propagated waves has to be received. So the pinna's job is to receive those sound waves and then direct all those sound waves to the middle ear, and that is done through the auditory canal. So the purpose of the auditory canal is to direct all the received sound waves to the middle ear. And the last part of the outer ear is what is the sense, and that's where we have the eardrum. So all the propagations, all the vibrations are to be felt on the eardrum, which also vibrates. And that's the starting, which means that it has sensed. Our ear has sensed the sound wave. Now, once it has sensed, the job of the middle wave is to amplify the sound wave that is just sensed. And it does that amplification by the help of three bones, which is anvil, hammer, and stirrup. And these three bones will amplify the sound waves that was sensed by the eardrum, by the vibrating eardrum. And once that is done, that is passed to the inner ear. And the main job of the inner ear is to convert that amplified sound wave into an electric signal. And that is done by cochlea. And the job of the cochlea is to convert the pressure variations of the amplified sound wave into an electric signal and pass it on to the brain. And that transfer to the brain happens through the auditory nerve. And once the brain perceives that, it means that we hear, and that's when we actually hear that sound wave. So this is how the human ear works. So with this, we come to the end of the exercises for Chapter 2 section. See you all in another video on another topic on physics. Thank you.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share, and subscribe this with your friends. Thank you.